Good morning. This is JVWU Dr. Vishal, Professor in Mathematics, JAYOTI VIDYAPEETH Women's University, Jaipur. Today we are discussing on the topic of cumulative frequency and cumulative frequency curves. This topic is a very important part of the subject statistics, and this is under the course of BPT 6th semester, under the course of research methodology and biostatistics, and under the program of BPT 6th semester and various other courses of the university. So in the today's lecture, we are discussing about how we can draw the cumulative frequency curves, and these curves are also known as ogives. So first, we should know here what is meaning of cumulative frequency. And the cumulative frequency means just we can define it. The frequency is the number of times an event occurs within a given scenario. Means how many times a data is repeated in our data set, that is known as frequency. So the frequency means just it is the number of times an event occurs within a given scenario, and cumulative frequency is defined as the running total of the frequencies. So means just cumulative frequency can be defined, can be taken as a running total of the frequencies. It is the sum of all the previous frequencies up to the current point. So for the current point, for the current just data set, data value, the sum of all the previous frequencies as well as the frequency for the current data is called the cumulative frequency, and it is easily understandable through a cumulative frequency table. So now we can understand this cumulative frequency by this table, and here we can observe that in this table just marks are given that while the frequency means the number of students who got these marks are mentioned. So marks in a marks are given that as a 0 to 5, like 5 to 10, 10 to 15, and 15 to 20. While the number of students that means it is frequencies are given by 2, 10, 5, and 5. And here we can observe that the cumulative frequencies, just we have already defined it above. So the cumulative frequencies are given by 2 for the data value 0 to 5 because the frequency is 2, and therefore the cumulative frequency is 2. For the data value 5 to 10, just the frequency is given there 10, and the cumulative frequency will be equal to 10 plus 2, and this is 12. In the similar way, next 10 to 15, the cumulative frequency becomes a 17, because 17 can be obtained by the frequency 5 and plus 10 and plus 2. That means sum of the current frequency 5 and all the previous frequencies. That means 10 and 2. So in this way, the cumulative frequency 10 to 15 becomes 17, and the cumulative frequency for the data value 15 to 20 is there 22. Just it is obtained by 5 plus 5 and plus 10 plus 2, and this is the cumulative frequency table, and in this way we can form it. This is a very important part of statistics, and it is very useful. Now later on we will discuss about this. So now we are discussing about the cumulative frequency curves, and these curves are also known as ogives. So first, initially we are defining this cumulative frequency curve. A curve that represents the cumulative frequency distribution of the group data on a graph is called a cumulative frequency curve, or and the ogive. So means just for the cumulative frequency distribution, a curve that represents the cumulative frequency distribution, just we have discussed earlier in the table, and for this cumulative frequency distribution, if a curve can be drawn, is drawn there for the such group data, then this is called the cumulative frequency curve, and the curve is also known as the ogive curve. Representing the cumulative frequency data on a graph is the most efficient way to understand the data and derive results. So this is a very important just part, and this will provide a great information to us, and just it is not very difficult to understand and to draw this curve. Now we are taking like in how many types of the cumulative curve, frequency curve can be divided. So the cumulative frequency curve can be divided into two parts, in the two types. First is called more than type cumulative frequency curve, and the second is called the less than type cumulative frequency curve. So first means the more than type cumulative frequency curve, which is also known as more than ogive, and the second curve is also known as the less than ogive curve. Now, just what are the meanings of the more than and the less than cumulative frequencies, and how can we how can we make them? We can understand here by this table. So, in this table, we can see just we are given that a group frequency distribution there, and the class limits are given, and the frequency is also mentioned there. So class limits like here 10 to 19, 20 to 29, 30 to 39, 40 to 49, and so on. And the frequencies like 2, 4, 7, 10, 16 are mentioned. Now in this question, because we can observe that the limit for the successive class intervals like here 19 means 19 is upper limit for this class interval 10 to 19, but 19 is not the same lower limit in the next class interval for 20 to 29. And in the similar way, uh, upper limit is there 29 for this class interval 20 to 29, but in the next class interval, 29 is not the lower limit, it is 30, and 30 means the lower limit of this class interval. And therefore, this type of series is called the inclusive data series. So first we have to convert in the exclusive form, and therefore just we have to first determine the class boundaries. Class boundaries can be obtained by just by a simple rule. Uh, 0.5 can be added in the lower limit for all the class intervals, while 0.5 is subtracted from the lower limits of the all class intervals, and 0.5 means half is added to all the upper limits in the successive class intervals. So, we can observe that in the first class interval 10 to 19 is there, and when we subtract 0.5 in the lower limit, then it becomes 9.5, and in the upper limit, because 0.5 is added there, so it becomes 19.5. While in the next class interval, it becomes 20, 0.5 is subtracted from 20, so it becomes 19.5, and 0.5 is added to 29, so it becomes 39.5. In this way, just all the class boundaries first can be calculated here, because we have to make the upper limit and the lower limit to be same there, because in the respective class intervals, in the successive class intervals. And now just we can observe that it becomes like 9.5 to 19.5, then 19.5 and 39.5, and it becomes here 39.5 to 29.5 to 39.5, 39.5 to 49.5, and so on. So next we have to make the cumulative frequencies. So cumulative frequencies are given by here less than and the more than. So for the less than cumulative frequency, we can observe that it is less than 19.5, less than 29.5, less than 39.5, and so on. So less than cumulative frequency can be calculated for the upper limits like 19.5, 39.5, 29.5, 39.5, 49.5, 59.5, and so on. While the more than cumulative frequencies will be calculated for the lower limits of the class boundary, such as 9.5, 19.5, 29.5, 39.5, and so on. Now, what are the cumulative frequency for the less than? Less than 19.5, the cumulative frequency is just given by 2. Less than, it is here 29.5, the cumulative frequency is given by 2 plus 4, that becomes 6. And less than, for the less than 39.5, less than or equal to 39.5, the cumulative frequency becomes 13. It is 6 plus 7, and so on. Now here, how can we make the more than cumulative frequencies? So more than cumulative frequencies, these are made for the lower limits of the class boundaries. So it is for the 9.5 or more. When the marks are 9.5 or more, then the cumulative frequency will be given by simply sum of all the frequencies. Like just we can observe that 2 plus 4 plus 7 plus 10 plus 16 plus 8 plus 3, and it becomes finally 50. Next, for the 19.5 or more, the cumulative frequency will be given by it is 4 plus all the succeeding, all the remaining frequencies for this class interval, means 4 plus 7 plus 10 plus 16 plus 8 plus 3, and it becomes 44 plus 4, that is 48. Now, more than cumulative frequency for the 29.5 or more. Now, how can we make it here? 7 plus 10 plus 16 plus 8 plus 3, and this becomes like 37 plus 7 and becomes 44. In this way, all the cumulative frequencies for the more than and the less than can be made. So these are just known as the less than cumulative frequency and more than cumulative frequency. And in the next part, now we understand how can we make the curves there. The cumulative frequency curve for the more than and for the less than can be drawn and is very useful. And these are also known as ogive curves. So less than ogive curve and more than ogive curves. So the graph given above represents the less than and the greater than ogive curves. The rising curve means the curve which is shown by the pink color there. The rising curve, pink curve, means representing here the less than ogive curve, while the falling curve means the curve which is coming downwards, and that is means by the blue color, represents here the more than or the greater than ogive curve. So these are the two curves. The curve which is coming downwards is called the more than frequency curve, more than cumulative frequency curve, while the curve which is just rising curve means it is given by the pink color, and it is known as a less than ogive curve. How can we draw these curves? It is important. Again, we come to the like here this table, and we understand then the less than cumulative frequency curve can be drawn in this way, like here. First, initially, we have to take our coordinate system. In the x-axis, we take the marks, means the limits of marks, and along the y-axis, we can take here the cumulative frequencies. So it means along the x-axis, we can take the points like 19.5 for the less than 29.5, 39.5, 49.5, 59.5, 69.5, and 79.5. So because these are the points here, 19.5, 29.5, 39.5, first we have to take these points, and the cumulative frequencies along the y-axis, like here 2, 6, 30, 23, these will be shown there. Now here just the point 19.5, 2, then 29.5, 6, and 39.5, 13, 49.5, 23, 59.5, 39, 69.5, 47, and finally 79.5, 50. Now these points just will be plotted there on the our graph paper, means on the XY coordinate system, and ultimately when these points will be made there, then we have to join these curves, these points. So just when these points are joined up, are just connected with each other, then this curve is called the less than Ojai curve or the less than cumulative frequency curve. Now in the similar way, we can draw the cumulative frequency for the more than, and that is also called more than cumulative frequency curve or more than Ojai curves. So for this here, again, in the similar way, we have to just first take the points on this coordinate system, like 9.5, 50, then 19.5, 48, 29.5, 44, 27, 39.5, 37, and 49.5, 27, 59.5, 11, and 69.5, 3. So these points, these coordinates will be just made on this coordinate system, on this graph for the XY, and means along the x-axis we are taking the cumulative frequencies, not cumulative frequencies. Along the x-axis we are taking the marks, and while along the y-axis we are taking the cumulative frequencies. So when these points will be taken on this system, on this coordinate system, then these points again to be just joined, and in this way the two curves, means the less than Ojai and the more than Ojai, will be obtained, and this type of figure is called just the this figure shows here the more than and the less than cumulative frequencies. Now one important thing, now we are going to discuss about this here, the concept of median for the cumulative frequency curve. So cumulative graphs can also be used to calculate the median of our given data set. If we draw both the curves on the same graph, the point at which they intersect, the corresponding value on the x-axis just shows the median of the given data set. That means when we draw the two cumulative frequency curves, the two Ujai curves uh, on the same graph, then the intersecting point of these two curves, means in the intersecting point of these two Ujais will just show the median. It's a x coordinate. Its abscissa part, its x coordinate will show the median of the given data set, and this is a very important point to be noted here. Just this median can be obtained by the cumulative frequency curves. Now, cumulative frequency is an important tool in the statistics to tabulate data in organized manner whenever we want to find out the popularity of a certain type of data or the likelihood that a given event will fall within a certain frequency distribution. A cumulative frequency table can be very useful. For example, the census department has the collected data and want to find out all the residents in the city aged below 45, and in this given case a cumulative frequency table will be very helpful. So in this way, the cumulative frequency table just shows the various types of information, like the residents whose age, the number of residents whose ages are below 45 can be obtained, and more than 45 can also be obtained by this graph. So this is a very important point. And again, a cumulative frequency curve in this graph is shown there. An OG curve is shown there, and it is from just a rising curve, and a rising curve just is shown there, and that means it is a less than type of OG. Just we have shown that The rising curve represents the less than cumulative frequency curve, and the curve which is going downwards means the falling curve shows the more than cumulative frequency curve. In this way, this graph can be understand here like this graph, this ogive is taken here, and this is showing here that this is moving upward, and that's why it is the less than cumulative frequency curve. And this is a very important part of our subject. So with this, I'm going to conclude my today's lecture, and it is a very informative session. It gives the knowledge of the cumulative frequency, and it's two type of curves, more than and the less than cumulative frequency curve. And we have related with these curves with median, a very important part. Median is a very important tool for the measure of central tendency. And with this, I conclude my today's session. Thank you.